Welcome back. Today we are going to delve deep into trig graphs and the unit circle. We're just going to look at just the basics of the graphs and the unit circle. So let's start. Trig ratios. We know 3, which is sine, cos, and tan. And we're going to first look at the graphs and what they look like and things like that. So sine graph, just start off with look something like this. It will pick 1, -1. We, I guess, stops at 1 and -1. This is the standard graph and what it looks like. It can always vary. Then for my sine graph kind of looks like a wave. It will peak at +1 at 90 degrees. Then it will pass through the x-axis at 180. It'll peak again, but now at -1 at 270 degrees. Then it will pass through the x-axis at 360 degrees. Okay, this is what the sine graph kind of looks like. Just the standard. Now for cosine, kind of looks somewhat similar, right, to the sine graph, but just its starting point is a bit different. So at 0 degrees, it will start at 1. And it looks something of the sorts like this. Give it a try. Oh well. So rather than starting at 0, unlike my sine graph, it starts at 1. Okay, and then it passes through the x-axis at 90 degrees. It peaks at -1 at 180 degrees, passes again the x-axis at 270, and then it will peak at +1 at 360. Okay, this is what the cosine graph looks like, right? Kind of similar to my sine graph, just a little bit different on where it starts. Okay, and this is one full revolution or one full rotation for my cosine and sine graph, right? It starts off at 0 degrees and ends at 360. That's just what one rotation looks like. Lucky last, tangent graph or the tan graph. Tan graph will looks a little bit different than the sine and the cosine, right? So the tangent graph will look something like this. It will have an asymptote at 90 degrees. Then it will continue on, passes through the x-axis at 180, and then another asymptote, which I will explain in just a second what it is. And then passes through the x-axis again at 360. Okay, so this is 270, this asymptote here, 270. Then it passes through the x-axis at 180 degrees, and the asymptote is at 90 degrees. So asymptote is basically, I would call it, this is how I remember it, an invisible line where the graph or the, I guess, function will never get to 90 degrees or 270 degrees. It'll reach so close, but it will never touch it, right? Just like an invisible line. Okay, I kind of remind it as the dome, that series, kind of like that. Okay, so that's the tangent graph, that's the sine graph, and that's the cosine graph. Let's move on to the unit circle. So the unit circle has something to do with circles, and it'll help us to find different triangles, but that's something later on. So to remember our unit circle, it's with the acronym of all stations to Central, right? It has to refer to something in Australia. And we're going to look at these, the capital letters. These will help us to remember what we need. Okay, ASTC. Okay, ASTC. All right, to draw a unit circle, this is how it's going to go. Right, I've drawn an X, my X and Y axis. I'm going to start at 0 degrees over here, 90, 180, 270, and then it goes back to here, and that makes 1 revolution. Okay. Now, I'm going to label it into different quadrants. So I'll call from 0 to 90 as quadrant 1. Okay. Then 90 to 180 is quadrant, just go quad 2. 180 to 270 is quad 3. And then 270 to 360 is quad 4. Okay. So these 4 quads would have a certain thing, right? Or something that would represent it. First off, in the first quadrant, this would be represented as just theta, right? Then from 90 to 180 degree, to find an angle between here in this second quadrant, what I need to do is then 180 minus my theta. Okay. To find an angle between 180 to 270, I would need to do 180 plus my theta. From 270 to 360, to find an angle there, I need to do 360 minus my theta. So my quadrant 1 sees where my theta is, quadrant 2, quadrant 3, quadrant 4, and so on, right? Those links here, these here, will help me find the angles depending on where it is, okay? All right, let's now use our acronym, all stations to central, and what does that mean? Well, all stations of central basically means all, means that all the ratios in quadrant 1, so sine, cos, and tan, are positive. For the second quadrant, stations means that sine is only positive. Okay. Quadrant 3 would be 2. So that means tan is only positive. And then my last quadrant means that cos is only positive. So it'll look something on the sort of this. So sine theta is positive, cosine is positive, and tan is positive. So sine theta, cos theta, tan theta, all in the first quadrant is positive. And you can look at it at the graphs here, right? I called this quadrant 1, 2, 3, 4. I've sectioned them into 4 different parts. If I look at the first quadrant here for the sine graph, to find out if it's positive or not, well, okay, is it above 0 or is it below 0? If it's above 0, that means it's positive. If it's below 0, that means it's negative. For the sine graph, it's positive in quadrant 1. Tick. For cosine graph, again, it's above 0, so that means my value would be positive. Then for my tangent graph right here, it would be, it's above 0, it's positive. Okay, all seems true. Now for my second quadrant, it means sine is only positive. So I'll go sine theta equals positive. Cosine, therefore, means that it's going to be negative, and same with tan. Okay, and again, I can represent it with my graphs. This part of the graph on sine graph, it's positive. For cosine, it's negative. And for tan, it's negative also. Okay, let's keep going. For quadrant 3, that means tan is positive. That means sine theta is negative, cosine theta is negative, and only tan, the value would be positive. Okay, looking at this part here. Okay. Then for quadrant 4, cosine or cos is positive. So sine theta and tan theta will be negative. And only cos theta would be positive. Okay. This is the basic unit circle. Super easy, but there is some
advanced stuff that you would need to use later on. So hopefully that makes sense, and I'll see you in the next one. Bye.